The previous lesson described the classic relational database approach and started comparing it to the MapReduce case. MapReduce is built on the NoSQL use case classification, and in this lesson we'll briefly discuss that in a little more detail. Um, and so, looking on 100,000 feet, or whatever what you want to call the high-level look is, the original cloud type solution for databases or data system was originally developed by companies like Google and Yahoo, or Microsoft with Bing for search, Amazon, eBay for commerce, and they needed cheaper, faster solutions than the current existing software, including relational databases, could provide. Um, then in the case of Google, Yahoo, etc., they built their own cloud infrastructure, and then along came Amazon, followed by many other companies which offered cloud infrastructure for sale, and that made new startups, including huge ones like Netflix, to totally outsource their computing in a very flexible fashion. So once you had that, then you also were able to rethink your software, and that's where Hadoop came along, which was the MapReduce model, which was it wasn't actually a revolution in terms of totally new ideas, but the way it was put together and its optimizations and an insightful design was revolutionary. That came from Dean at Google, but Hadoop itself was the software for MapReduce developed at Yahoo, and that's a very important driver of this whole field because Hadoop was donated to the Apache Foundation and developed as an open source process. And now we'll find the so-called Apache Big Data Stack, which in my opinion is incredibly important. And there's a particular Apache project called BigTop, which has a lot of those big data projects in it. And those are driving a lot of the innovation and actually production use of clouds by companies in this internet cloud arena. And we already saw Cloudera, whose business model is it's like Red Hat for Linux. It involves supporting and enhancing the Apache Big Data Stack. But if you look at the so-called Hadoop project, one part of its ecosystem is HBase, which is an open source version of Bigtable, which was the original Google data management system built to support a sophisticated set of highly flexible distributed tables. See, this is no miracle. Tables are table structures familiar from spreadsheets. Its value is obvious. And in fact, relational databases are built around tables. But in the case of HBase, these tables are intrinsically distributed and designed to be highly efficient when run in parallel. A key aspect of HBase and Hadoop is they use HDFS, the Hadoop file system, which is an open source version of the Google file system. And the key feature of this file system, usually when you have a file system like Network File System, NFS, or Andrew, the files sit outside the compute cluster and they're fetched using Unix commands into your compute environment. But HDFS takes seriously the concept of bringing the computing to the data, not the data to the computing. The classic model brings the data to the computing, and they have the data stored on the same node that does the computing. And HDFS supports this type of data, this type of file system, which is spread over the compute nodes. And there is, of course, something similar with relational databases, but the data in a relational databases is stored in a highly optimized fashion and doesn't have a general purpose file system behind it. Then relational databases, we have SQL processing the data. In the case of this Apache Big Data, we have MapReduce processing the data. And that's written in Java, and you write your processing in Java, or maybe some other language which you can interface to express the processing. Hadoop runs maps. It's the MapReduce model. So the maps are just things that transform data, which apply analytics to the data. And they use this typically almost always use, like most things in parallel computing, the single program multiple data model, where every map processes a part of the data. Then after a wave of maps and the data is processed, then the data is still sitting in the independent processes that did the parallel job. Typically, they need to be integrated, and that's where the reduce step comes in, integrating results of all the maps to get the final answer. So that's the MapReduce model in a nutshell. This nice plot here gives the current state of the Apache Big Data Stack. We have at the bottom HDFS, the file system I mentioned. We have schedulers, because you have to schedule jobs on top of that file system, which are called Mesos and Yarn. Then we have the various NoSQL data managers, HBase, Cassandra. Cassandra does not use HDFS. And then we have these are just the NoSQL ones which are in Apache. Other NoSQLs like MongoDB are not in Apache. Accumula, which I'm not actually personally so familiar with, it uses HDFS. Then we have, after the data managers, we actually have to process the data. We have Hadoop. And then we have variants of Hadoop, which we'll mention later on, Spark, Tez, Hammer. And then we have the streaming. I pointed out Hadoop is sort of the batch model. You run a lot of data. Then you have the model where the data comes in one at a time. We have Storm, S4, and Samza. And then finally, you have the special type of processing needed, which we already mentioned, for graphs, where there is the Giraffe project. Above all of this, you have higher level abstractions. We have Hive, which is SQL built on top of Hadoop. We have Pig, which is a procedural language for people familiar with, say, older scientific things. There were things like Fortran 90, high performance Fortran, array languages. MATLAB is like that. So Pig, as you like, is a MATLAB-like syntax for doing general data processing. Then we have Spark is a variant of Hadoop, iterative MapReduce. And then you have Shark as a SQL on top of Spark. It's not yet an Apache project. Another SQL on Hadoop and Hammer and Spark, SQL on HBase, and object stores are another way of storing data in clouds, and that's where Goro comes in. So these are high-level abstractions. And on top of this, you have the actual analytics, Mahout, MLlib, and MLbase. You have running across all these subsystems, you have message protocols, Thrift, distributed coordination, and concurrency control, Zookeeper, JGroup, Hazelcast. We have communications, which are typically message brokers, Netty, ZeroMQ. MQ is message queuing. There's lots of MQs in the world. ActiveMQ is another one mentioned there. Cupid, Kafka. These are all different messaging systems. And then actually the tool which is generally used but is lower level is actually deploying the clouds where you have WIR and JCloud. So this points out that we have today from Apache, Apache is tomorrow's Oracle in some sense, or tomorrow's SAP, where it offers in an open source fashion a complete package. Now, to make all this work, you either have to hire some brilliant people, or you go to a company like Cloudera, or maybe you contract with your favorite university to integrate all this together to get what you want. So that's the Apache big data approach, very important. Here's a comment from eBay on all this stuff we've discussed about the difference between Hadoop and HBase and Teradata, which is a typical data warehousing solution, and Cassandra or MongoDB, which are a different type of document-oriented NoSQL store. And they all have different trade-offs, and you're likely to need all of them if you want to put together a real problem. Let's remember when we discussed the IBM and Oracle solutions. These were ones, they had to support everybody. That's the nature of such big organizations. It's why nifty startups can be effective. They can just focus on one thing and do it incredibly well. They're not responsible to do everything, but IBM and Oracle and have to do everything. So you need to generate an insight into the different capabilities and choose what you want to use for your particular problem.